Hello, welcome to example 5.7, and this is in response to our assignment question to explain the concepts, the physics concept that surround the question. So let's get into it. The question says two blocks with masses m1 and m2, with m1 greater than m2, are placed in contact with each other on a frictionless horizontal surface, as in the figure, and this this is the figure that we're referring to. The constant force, horizontal force F, is applied to M1 as shown in the figure. Find the magnitude of the acceleration of the system. So first of all, we have to understand that this is a horizontal surface and it's frictionless, so we won't have any opposition to motion. And also, we also have to understand that the force is in the horizontal direction. That means we can use the Newton's law of motion, second law of motion, which states that the applied force is directly proportional to the acceleration of the system and is inversely proportional to the mass. In this case, our mass is M1 and M2 because these are the two blocks that the force is being applied on. It's applied on M1, but eventually it's going to be M1 plus M2. So we're going to treat M1 and M2 as one mass. So that's why from the second law of motion, we can state that the summation of forces is equal to the mass times acceleration. Because we're treating M1 and M2 as the mass, we can do M1 plus M2. And then we have to specify that the acceleration is in the horizontal direction. So M1 plus M2 times AX. We could just make AX the subject of the equation by dividing both sides by M1 plus M2. So divide both sides by M1 plus M2, we will get that AX is equal to F over M1 plus M2. And that is how we get the answer to the first question, the magnitude of the acceleration. So the second question says, determine the magnitude of the contact force between the two blocks. So let's draw a diagrammatic representation of the forces that are acting on each block first, so that we can understand what the question is asking. So this is each block, all right? And here we can see block 1. It's not horizontal, forget my diagram. But this is the normal force, as we know, acts opposite to the gravitational force and perpendicular to the surface. This is the force that has been exerted on block M1. And this is the contact force on M1. This contact force is being exerted on M1 by M2, because then when both of the blocks hit together, M2 is going to exert a contact force on M1. Now on M1 times G, this is just the acceleration due to the force of gravity on M1. So now that we know this, this is the M2, the same thing, the contact force, the acceleration, gravitation, because of gravitational force, and the contact force. Now, the diagram, the direction of this contact force is key. The contact force on M1 is moving to the left because it hits M2 and it has to go to the left. The contact force on M2 is moving to the right because then that's the direction of the force. So now that we have established all this, okay, we can now say that the summation of force is equal to the contact force on M2 because, like I said, it's moving in the direction of M2. You understand? And also because M1 is larger than M2, that means that the summation of force that has been exerted on the system is equal to the contact force that is being exerted on the M2. And like we already stated before, from Newton's second law of motion, this is equal to M2 times AX. So we just substitute our expression for AX into this equation, and that's going to be M2 times AX, which was F over M1 plus M2, and that will give us this. Now, Newton's third law of motion states that action and reaction is equal and opposite. That means that P12 is equal to P21 because then they're equal and opposite, and that gives us both P12 and P21.